On example 6, find the derivative with respect to x of c times f of x, where c is a real number. Now, to be honest with you, we've kind of already assumed that this derivative rule that we're about to show is true. Actually, it already works. We did it here. Let me show you. Back over here. Whenever we took a second derivative, of this thing, and it had a 2/3 right in front of it, and we just multiplied that power down. We did that illegally. We did that without knowing that we were allowed to do it. Shh, I won't tell anybody if you don't. So now we're going to actually prove that it works, okay, using the limit definition rule. You know, that's just how we do it. So let's apply the limit definition to the derivative of c times f of x. I'm going to have the limit as h goes to 0 of c times f of, and inside of the function we got to put x plus h, minus f of, whoa, don't forget your c, c times f of x, all of this over h. Okay, notice that across the top we have a common factor of c, which can be factored out. So I'll factor that out. Limit h goes to 0, c parentheses f of x plus h minus f of x, all of that over h. Some of that looks familiar, of course. All right, and you may remember from another lesson when we were talking about limits and how to deal with limits. If you have a limit of a product of two things, that is the product of the two limits, assuming the two limits exist, of course. So I can break this up as the limit as h goes to 0 of c times the limit as h goes to 0 of f of x plus h minus f of x, all of that over h. Oh, that does look familiar. All right, let's take this piece at a time. What's the limit as h approaches, that's a 0, by the way, of c, where c is some sort of constant? Well, that should be equal to that constant, right? It doesn't change. How about the, wait, I think I recognize this for sure. It needs pink. This is f prime of x, right? That's the limit definition of the derivative, times f prime of x. What that means here is that that constant kind of carries through. So whenever we did it back up here, that's basically, where did we do it? We did it right about here. That constant just carried through, and that's exactly how you deal with constants. So coming back over here, we have what's called the constant multiple rule. The derivative with respect to x of c times f of x is c times the derivative of f of x. Again, c is some sort of real number. So what this means is, like you can see from the picture here, that we have a function, and then we have scaled it vertically by 2. What does that do to the derivative? Well, it also multiplies it by 2. In other words, your graph just got twice as steep, and steepness is all about slope, and slope is all about derivatives. All right, then, let's try this on a couple of examples. Find the derivatives of each of these functions. So I'm going to come back over here where I have some room to write. And again, I'm going to have to rewrite my equations to make it easier to apply all of the rules that we've learned thus far. Y is equal to 2x to the negative 1. And now I am using both the constant multiple rule and the power rule. I'm going to take that negative 1 and multiply it times the 2 that's there. So y prime is equal to negative 2x to the, decrease the power by 1, negative 2. And I might rewrite it one more time so I don't have negative exponents, x squared. Okay, there's nothing really to rewrite on this one. Our independent variable here is t. So f prime of t is equal to, I'm going to leapfrog this 2 down. It's going to multiply times the 4 and make that 8/5 t to the first power. But I'm not going to write the 1. Okay, so again, I need to rewrite. I need to do some rewriting before I differentiate. I'm going to have 1/2 as my fraction. And then my x here is to the 2/3 power when it's on the bottom. But when I bring it up to the top in order to actually take the derivative, it's going to be negative 2/3. Now let's take its derivative. Y prime is equal to, now multiply the 1/2 times the negative 2/3. I'll write it down for you in a separate step if you want. And then x to the, it's going to be a negative 2/3 that we're going to have to subtract 1 from. Oh, look, Look, I'm actually writing steps down. Okay, let's cancel some stuff out like these 2's. And I'm going to have negative 1/3 as my coefficient, x to the... Now what's negative 2/3 minus 1? 1 is 3/3, so that's going to be negative 5/3 there. And then with a negative exponent, let's make this look like what we started with, negative 1 over 3. This will be the cube root of x to the 5th. That looks real nice. All right, in the next video, we're going to learn how to come up with this thing called the sum and difference rules.